We are doing trigonometric integrals. Today's example is find integration secant cubed x dx. This problem is the most complicated problem in this section. We have integral secant cubed x dx. With this, what we will do will be splitting this into secant of x times secant squared of x dx. Obviously, we cannot do substitution method with this. What we will do will be the integration by parts by putting this one as u and this one as dv. U will be set as secant of x and dv is set as secant squared of x dx. So du equals secant of x times tangent of x dx. We just differentiate and we use the formula. We integrate secant squared, then that is tangent of x. That also came from the formula. The integration by parts formula goes like this. We multiply u by v. So that is secant of x times tangent of x minus integration. Tangent make tangent squared. Tangent squared of x times secant of x dx. Then if you look at this again, it is impossible to use substitution method. If you differentiate tangent, then that should be secant squared. But if you differentiate secant, then you have to get secant and tangent. And so the problem is there is no square in secant. So what we will do will be, we will use the Pythagorean identity, which is tangent squared of x equals secant squared of x minus 1. So that is secant of x times tangent of x minus integration. Tangent squared is secant squared of x minus 1, secant of x dx. And then that becomes secant of x times tangent of x minus integration secant cubed of x dx plus, because minus will make plus, integration secant of x dx. From here, what you notice is at the beginning, we start with secant cubed of x, and in the middle, the same thing appears here, but there's minus here. And by the formula, this one will be natural log of secant plus tangent. So let me write down. Secant of x times tangent of x minus integration secant cubed of x dx plus natural log of absolute value of secant of x plus tangent of x. So what we will use will be this secant cubed of integral of secant cubed of x dx is this equals this, but this one and this one are the same. So what I will do will be I will add the same on both sides. So then apparently these will cancel each other. On the left side, integration of secant cubed becomes 2 times integration of secant x dx, right? So we are getting 2 times integration secant cubed of x dx. That equals secant of x tangent of x plus natural log of absolute value of secant of x plus tangent of x plus c. So we multiply by 1/2 on both sides, then we get the final answer. So we are multiplying by 1/2 on both sides. Then those two will cancel each other. So on the left side, secant cubed of x dx. And on the right side, we have 1/2 times open parenthesis, secant of x, tangent of x, plus natural log of secant of x, plus tangent of x, close parenthesis, plus c. We don't have to multiply 1/2 to c because c is a random number. Again, could you please activate your camera? Otherwise, I cannot see whether you are following me or you copied it, everything. So I may just go a lot faster if you don't activate your camera. Sine of A times sine of B. I am talking about the formula. So sine of A times sine of B is 1/2 times cosine of A minus B minus cosine of A plus B. These formula will not be given in the exam, so you have to remember. Sine of A times cosine of B equals 1/2 sine of A minus B plus sine of A plus B. And the cosine of A times cosine of B equals 1/2 cosine of A minus B plus cosine of A plus B. We will need that formula to evaluate the integral. Integration sine of 4x times cosine of 5x dx The formula we will use will be the second formula because sine and cosine are combined. So we will rewrite that as 1/2 open bracket sine of 4x minus 5x because A minus B and then sine of A plus B. So plus sine of 4x plus 5x dx. The important point you have to observe from here is the first thing you would think about is whether the substitution method works. But unfortunately, there is 4 in front of x to sine and 5 in front of x for cosine. So those are not the same angle. So we cannot, those are not related to each other as a differentiation. So we cannot use the substitution method. However, if we use the formula, then we can separate that into 2 pieces. So we will do term by term differentiation or the integration. 1/2 will be written here, and then that is sine of minus x plus sine of 9x dx. In this case, sine of negative x can be written as minus sine of x because sine is an odd function. And then we will apply the formula for the sine. Integration of sine x dx is negative cosine x. So for the first one, that becomes cosine of x because there is negative in front of that. Negative will make plus. And then this one will be minus cosine of 9x but we have to divide by the number in front of x plus c. So finally, I think you can conclude the problem like here, where you can write 1/2 cosine of x minus 1/18 cosine of 9x. Plus c.
Excuse me.
Yeah.
First Quan. How do you know like what makes it important that it's an odd function and not an even function, and that's why you could take out the negative?
Yes. Yeah, so let's review the trigonometry fact. Sine is an odd function. That means if you change the x value and flip it, so minus x, and then y value changes the sign, right? That is the odd function. And so sine of negative x, if you go from here to here, then its function value switches the sign. So that is the odd function. If you think about cosine of negative x will make cosine of x, because cosine is an even function. The cosine graph look like this. So if you flip along y-axis, then left side and right side are the same. So if you flip around y-axis, then even if the sign of x is different, the function value stays the same. So that is the meaning of even functions. So those are the things which you learned in trigonometry. And that is the last thing we had to cover in 7.2. 7.3 is about trigonometric substitution. The type of question we will deal with will be like, what is integration of square root of a squared minus x squared dx? This doesn't look like a trigonometric function, but in some sense that makes you think about the Pythagorean formula or trigonometric Pythagorean formulas. So we will use trigonometric substitution. To do trigonometric substitutions, there are important key formulas from trigonometry. As I said, we will think about Pythagorean formula, trigonometry version of Pythagorean formula. Those are sine squared of theta plus cosine squared of theta equals 1, or 1 plus tangent squared of theta equals secant squared of theta. The following things which I will put in the table should be remembered. You have to remember all of those very clearly. Those are related to the strategy. On the left side, I will write the expression. We have a squared minus x squared. Then the identity we will use will be 1 minus sine square root of theta equals cosine square root of theta. So the reason, of course, a is a number. 1 can be regarded as 1 squared, and then x can be related to sine squared. The basic strategy with the substitution will be x equals a sine of theta if we have a squared plus x squared, then we will think about 1 plus tangent square root of theta equals secant square root of theta. And then we will put this one tangent as x. By doing that, what we realize will be we can remove this square root, right? The next one is x squared minus a squared. Then the identity we will use will be secant squared theta minus 1. That equals tangent square root of theta. So x equals a secant of theta. By doing that, after remove this one, it'll become tangent. As I said, you have to remember this one very clearly. How to relate this with our identity, especially this substitution part. If you're confused with the formula, then you cannot start the problem at all. Let's start with the pattern square root of x squared minus a squared. Then I said substitution must be done with x equals a secant of theta. Evaluate integration of square root of x squared minus 36 over x cubed dx. So this is the same as this pattern. And so A will be 6, right? Let me rewrite square root x squared minus 36 equals square root of x squared minus 6 squared. Let x equals 6 secant of theta, because this will be written in front of secant. Then we know that dx equals 6 times secant theta times tangent theta d theta. So when we think about x squared minus 36, that'll become, after the substitution, that'll become, we square this. So 36 secant squared of x minus 36, right? Right. So we have common factors 36. So square root of 36 open parenthesis secant squared of x minus 1. Secant squared theta minus the actually I have to write theta here. Theta. Square root of 36 is 6, and secant squared minus 1 is tangent squared of x, right? So this becomes square root of tangent squared of theta. So that is 6 tangent of theta. Let's do integration. Integration of square root of x squared minus 36 over x cubed dx. So that equals, this square root equals 6 tangent theta. So 6 tangent theta over x was 6 secant theta. So it becomes 6 cubed secant cubed theta times dx is 6 times secant theta tangent theta d theta.
Why is it being changed to terms of theta?
Because we are doing substitution with a trigonometric function. So if we keep x, then indeed this x is the function value of secant, not theta, right? And so we cannot write that as 6 secant of x, but I'm not sure whether I'm answering
Just 'cause
the
it's
point of your question. What?
Okay, never mind. I understand. It's okay.
Yeah.
It's because it's in the trigonometric. Okay.
Yeah. So we have to think about the angle, right? So what happens here is 6 times 6 will make 6 squared, right? And then we compare this one in the numerator and this one in the denominator. The formula we know is a to the n over a to the m equals a to the n minus 1, right? So when we simplify, that becomes what? 6 to the negative 1, which is 1/6, right? That equals 1/6 integration if we multiply these two, then you will get tangent square root of theta. And if you compare these two, then you have to erase one power in the denominator. So it becomes secant squared. So let's summarize. The numerator will have tangent square root of theta, and denominator will have secant square root of theta d theta. Now we have to do simplification. Let's do that. Tangent square root of theta over secant square root of theta equals tangent square root of theta times 1/secant square root of theta. So tangent square root of theta is sine over cosine. So sine square root of theta over cosine square root of theta times secant is the reciprocal of cosine. So this part will become cosine square root of theta over 1. When we simplify, we get sine square root of theta, right? So that's the simplification. This is sine squared of theta. We go back to the integral, then that is 1/6 integration sine square root of theta d theta. So that is 1/6. We apply the half angle formula, then it becomes 1 minus cosine of 2 theta over 2 d theta, right? So from here to here is the formula which you have to remember. So this, I have to write integration. We will multiply 6 and 12. So we write 1/12 in front of integral. And then 1 minus cosine of 2 theta d theta. So we have 1/12. If we integrate 1, then that becomes theta minus, we divide by the same number in front of theta. So 1/2 sine of 2 theta plus c. You may feel momentarily that maybe we finished the problem because there is no integration. But we have a problem because we started with the variable x, but we did trigonometric substitution. So we changed the variable to angle theta. So we have to recover the original variable, which means the final expression must be something to do with x, not theta. So what I will do will be, I will use the double angle formula. So 1/12 times theta minus 1/2 sine of 2 theta is sine theta times cosine theta plus c. Here, what I used is double angle formula for sine. So sine of 2 theta can be written as 2 times sine of theta times cosine of theta. So I have to write 2 here, and then do the 2 will cancel each other. Again, this double angle formula should be remembered. So that is 1/12 theta minus sine of theta times cosine of theta plus c. Why are we doing that? That is because we know x equals 6 secant of theta. So from x equals 6 secant of theta, which was given, we get secant of theta equals x/6. I just divide by 6 on both sides here. Then we know that that is 1 / cosine of theta, that is x/6. And then we just flip both sides, then we have cosine of theta on the left side, that is 6/x. That comes from what? Adjacent over hypotenuse. So by going through this, what you realize is a cosine of theta is 6/x. So this can be converted, and also we can write theta is secant of theta is x/6. So theta equals secant inverse of x/6, right? We just take inverse function on each side. But so we know this one and this one, but we don't know sine. So from this information, we have to draw a right triangle here. This is theta, and adjacent is 6 and hypotenuse is x. So that is square root of x² minus 6². From here, what do we get? We get sine. Sine of theta equals, that is opposite over hypotenuse. Here, theta is attached to the horizontal side, so that is adjacent. This is opposite, and x is hypotenuse. So opposite is square root of x² minus 6² over hypotenuse is x. So that is sine. So let's do substitution. Cosine is obtained here, and sine is obtained here, and theta is here. All we need to do is substitution. So 1/12, theta was secant inverse of x over 6 minus sine of theta is square root of x squared minus 6 squared over x times cosine is 6 over x plus c. So if you go further, then you can do a little bit more. 1/12 secant inverse of x over 6 minus, we are doing distribution. 1/12 times x will make x squared. Usually we write the number in front of radical sign. So 6 x squared minus 6 squared plus c. Any question? This is pretty long problem. As I said, if the pattern goes like square root of x squared minus a squared, then strategically, we will write x equals a secant of theta and then proceed the calculation and then substitute back by drawing the triangle. Next one, maybe a little bit elusive. By using the technique we discussed, we still can solve the problem, but that'll give you the detour. So this problem is presented to ask you to be careful. If you understand that x squared minus 5 as x squared minus square root of 5 squared, then you feel like you have to do trigonometric substitution. But before we do that, if we look at the numerator and denominator, then when you differentiate x squared minus 5, you will get something to do with x dx, right? So in this case, we will use a regular substitution. What we will do will be, we will put u as what's under the radical x squared minus 5. Then du equals 2x dx. And then we look at x dx, then that is 1/2 du. So integration x over square root of x squared minus 5 dx. Then that'll be 1/2 integration 1 over square root of u du. Because this part is 1/2 du, right? So we can write the number in front of integration. Then we can rewrite that as 1/2 u to the minus 1/2 power du. And then we just apply the normal integration formula. So u to the minus 1/2 plus 1. We have to divide by the same number. Then negative 1/2 plus 1 equals 1/2 because 1 is 2/2, right? 2 minus 1 is 1. So it becomes 1/2 times u to the 1/2 over 1/2 plus c. So this number and this number are the same, so they will cancel each other. And we get 1/2 u to the 1/2 power plus c. U represents x squared minus 5. So this one is a square root of u. So that becomes square root of x squared minus 5 plus c. Any question? I think you are taking an exam in 2 weeks, right? For the exam preparation, of course, the type of question which I'm giving you as a quiz problem is very likely to appear, but it doesn't mean that the same function will appear. I will definitely change the function. So I suggest you to master the cylindrical shell method and disk method, Washer's method, and how you can calculate the same object differently, because definitely I will give you that kind of question. And as I said, you have to make a formula sheet, and while you solve the problem, you have to understand how you apply the formula, but at the same time, you have to remember the formula and pattern of the problem. And for the, if you look at the lecture note, then lecture note covers, I think, all pattern of the problems which appear in the web assign. So when you study for the exam, it'll be very effective to go through the lecture note and try to understand and summarize all the pattern and formula, and then just regard all the examples as if those are exam problems, and then you can see the solution in the lecture note, and so you can compare your solution with what I wrote in the lecture note. And then I think that's the best way to prepare for the exam. So basically just understand and summarize the formula and strategy together and remember those, and then go back to the examples I present, and then work out those problems as if you're taking an exam. And then definitely exam problems will be a lot easier than homework problems, which means the problems I'm presenting. So you will do very well. But as long as you start to be confused with the basic formula or strategy, then you will suffer from lack of time, and your exam score cannot be good. Especially if you don't remember the formula, then starting point is wrong, and then you're losing most of the point. I cannot just give the point if the starting point is wrong, because you are just proceeding with the wrong calculation of process. So just prepare the exam little by little, and hopefully everybody will do well on the first exam. Do you have any question about the exam or any other course policy? No, the department asks you to remember all the things. What topics? If you look go to the website and go to the course page, and then you will get the information. I cannot remember the section number right now. I have to open the web courses. Do you have any other question? You can write it down in the chat box if you want. No, what I'm saying is the our department standard is not giving you the formula sheet, and you cannot refer to your formula sheet. Handmade formula sheet or lecture note is allowed during the quiz so that you can master and understanding things while you discuss with others. But exam is different. The exam is testing about whether you master the subject rather than understanding. So purpose of quiz and exams are different. Do you have any other question? If you don't, then you can leave. But if you have question, then you can remain and continue to ask me question.